Hey boys and girls, this is Miss Botta with Chapter 5, which is the movement of ocean water. We're going to start with Section 5.1, which is about ocean currents. Now in this chapter, remember that there are several things that we've already learned, so you'll see how all of this ties in together with some previous learning that's taken place. First, we have ocean currents, which are stream-like movements of ocean water. Currents can be influenced by a number of factors including weather, Earth's rotation, and the positioning of the continents. Then from there, we have two types of currents. We have surface currents and deep currents. And I'll give you a minute to get caught up. Surface currents are the horizontal movements at or near the ocean's surface. And these surface currents are controlled by three things: global winds, the Coriolis effect, and the continental deflections. Now, we did a thinking map on this, so you should have all of this information already. Okay, with global winds, at the equator, the winds are going to blow from east to west. And at the polar regions, or the poles, winds will blow from west to east. With the Coriolis effect, remember this is the curved path of winds and currents. So this is what gives the winds and the currents both that curved line rather than a straight line. And with continental deflections, this is when the currents have to change direction because they were run into a continent. Sorry, there was Mr. Graham distracted me. One example is the Brazil current. Then when we move to deep currents, these are stream-like movements of ocean water that are far below the surface, not up at the top, but far below the surface. And unlike surface currents, the deep currents are not controlled by the wind, but they are instead controlled where density increases. Now, density is the amount of matter in a given space or volume. And the density of ocean water can be increased by two major ways. One way is by increasing salinity, and the other way is by decreasing temperature. Now you say, what is salinity? That's how much salt, dissolved salts or solids, there are in a liquid. Now on your paper you'll see three ways to increase salinity, and that should really just be two ways. So two ways to increase salinity is by freezing and by evaporation. Now farther down on your paper you'll see diagrams that show this. Now over in the first line, this is where you need to put density is increased by decreasing temperature and also by increasing salinity. So density and salinity all really go in together. So make sure that you look at the diagrams. It's on page 127 in your book, and so that you can really understand density and salinity and how it all kind of ties in together. I'll put the rest of this up in a day or so. Have fun.